right, I'm going to play this video. This video. Okay, and
there are different types of analysis of variance. This video is about one way or single factor analysis of variance without measurement.
okay. Before I start, I want to say one thing. That why do we need to run the ANOVA? Actually, early this May, I showed you that one student from our department, we conducted the research about the sugary drink intake from international students. We compared before they arrived Taiwan, after they come to Taiwan, and we compared the sugar intake, and we compared the different groups. Then we found no significant difference. No significant difference. Okay, now I'm going to tell you that is another different tool. And when we compare two groups, only two groups, we can use t-test. And but if we have more than two groups, how can we do? We can use another tool that is called ANOVA. ANOVA here is analysis of variance. Okay, where is the variance? What is the variance? According to the chapter 3, the definition is variance is a calculation to check how far away for each sample from the mean. Okay, but actually we familiar with another term that is standard deviation. Standard deviation, or we call SD. Standard deviation is easier to understand because we are familiar with this one. Actually, variance is the square value of standard deviation. It's easy. You don't need to take the square root of it. You just use the original. That is square value of it. Each sample minus sample means and take the square value. That is a variance. Okay, and now, okay, let's study this one, this video. Here, single factorial without measurement, repetition, single factor with measurement, repetition, two factors. Okay, let's check it. Okay, it's an extension of t-test. Actually, in previous days, I told you that there are three kinds of independence tests. So there are three types of t-test. One is one sample to check the sample whether it's from a big population. The second one is two groups comparison. Third one is paired T. For example, two groups of patients before they drink black tea, after they drink black tea, any change, I mean the blood sugar or the blood pressure or the cholesterol in blood. And the kind of test we call paired T test. Sure, I will give each section in our final exam. I will give you the hint. Okay. And now more than two groups, there is another tool called one-way ANOVA.
When calculating an independent t-test, we look at whether there is a difference, or more precisely a difference in means two examined groups. For example, if there is a difference in the salary of men and women. In this case, we have two groups, want to get more than 3 independent groups, we use the analysis of variance. In case of the t-test, we use the independent t-test if the 2 groups or samples were independent. This is the case if one person in the first group has nothing to do with the person in the second group. Exactly the same now applies to the analysis of variance without using the measure. Except that here we have at least 3 independent samples. If we have more than 2 dependent samples, we would use an analysis of variance with repeated measure. Now let's look at an example. Let's say that as the founder of Kozak, I might be interested in whether there are differences in age between people who use videotape, SPSS, or R. In order to do this, I take a sample of people who use statistical software and ask them which statistical software they use and how old they are.
Actually, SPSS, it costs your money. You need to spend R. You don't need to spend money on R, but it's a bit complicated because it's a terminal. Terminal, it means you need to type the commands on the computer, not a graphic interface. And so I encourage you to use Google Office and online applications. They will be easier and you don't need to waste your money. Sure, in the future, if you got a job from somewhere, you need to use different way, and it's a different issue. We can discuss it later. Okay, again, through 2 groups, we can use paired T or independence T test. But now we have 3, 5, 6 or more, and the other way is to use one way ANOVA.
In order to analyze this example, I will now use ANOVA. So the next question is, what is the research question I can answer with using an ANOVA? The research question is there a difference in the population between the different groups of the independent variable in relation to the dependent variable? The independent variable is the variable with different categories. In our example, it is the statistics software used. Here we have the 3 groups, dataset, SPSS, and R. The dependent variable in our example is the age of the software user. We would like to know whether the groups of the independent variables have an influence on the dependent variable. Of course, the analysis of variables does not give us any information about the direction of the causal relation. Unlike our research question about the population, we just had as an example, actually we want to make a statement about the population. Unfortunately, in most cases, it is not possible to study the whole population, and we can only draw a sample. The aim is to make a statement about the population based on our sample with the help of the analysis of variance. For our example, the question would be, is there a difference between the users of different statistical software solutions in terms of age? But what about the hypothesis? In the case of the analysis of variance, the null hypothesis is that there are no differences between the means of individual groups. We have our individual groups of which we can calculate.
Actually, this semester I lowered the part of about explaining null hypothesis. Actually, I don't like the kind of use. It's very it's a little bit of redundancy. But in the future, I believe when you enter the graduate school, you will learn this. Let me have explained it a little bit. Null hypothesis, alternative hypothesis. I forgot which scientists established these rules, but in short words, there are 2 hypotheses. One is null hypothesis. It means before we test the groups, test the samples, no differences. And as long as your p-value smaller than 0.05, or you can set your own critical value. As long as your p-value is small enough, you can reject non-hypothesis and accept the other one. That's called alternative hypothesis. But it's a little bit redundancy personally. But I will explain it like this way. After we conduct the analysis, we got a p-value that is 0.001, and we know there is a significant difference, and those two groups are different. Okay, and actually, our previous test, I selected the information from the website from this lecture, and her lecture is really good. And she made up a test about female and male. Do they have different preferences in selecting newspapers, including Washington Post, WSJ, and New York Times, New York Post, something like this. After we conduct the analysis, the p-value is far away. So the x-squared sum is far away, the smaller than the critical value, and we know no significant difference. Okay, go ahead.
Then our null hypothesis is that there is no difference in mean estimation. The alternative hypothesis H1 is that there is a difference between at least two groups. Therefore, our null hypothesis assumes that there is no difference, and the alternative hypothesis says that there is.
Okay, again, the alternative hypothesis H1, that is at least two groups, means differ from each other in the population. Actually, group 1, 2, 3 from the diagram, I love this kind of visualization. It's very clear. And from the figure, we know the border line here, it means the average below the group average. Here is above the group average. And the other hypothesis, alternative hypothesis, at least two groups means differ from each other in the population.
All well and good. Now we know what the null hypothesis is, but what does this mean graphically? How can one picture that even more? Let's say we want to test whether there is a difference in salary between the three groups, 1, group 2, and group 3. The salary has some dispersion. Some people earn 400 euros a month, some 2,600, and others 6,000 euros a month. Thus, both in relation and in our sample, the salary is broadly different. Now the question is, where does this variation come from? And can we explain some of the variation by these groups? So how much of the variation in salary can be explained by dividing the people into these three groups? In the extreme case, the result would be that the salary in group 1 has this distribution, in group 2 that distribution, and in group 3 the distribution would be like.
Okay, again, from this group, and the whole group of there, whole population of there, and divided into three groups. The first green people group, the salary average is a little bit low. The red people average, that is a little bit high. The yellow people average is in the middle. And sure, it's a diagram, it's a visualization. We can see, wow, they are different. Their income, their average, their standard deviation is different, but it's a visualization. However, when you want to tell your friend, after my research, I found those three groups has different salary average. No, how can you prove it? You say, I conducted the analysis that is called a one-way ANOVA. Okay, it can convince me. You can convince me. Okay, go ahead.
In this case, the division into groups could explain a lot of variance and variable salary. The result would be different in this case. Here, however, we could explain almost no variance that falls into the group. Within the group, the variance is almost the same as in the first.
Yeah, from the second group, the graph, we can see that the distribution from high income to low income is a little bit wider, and those three groups has similar situation in the group. Green group, red group, and yellow group, they have a similar situation, and we cannot say maybe they have different salary, maybe they have the same or similar, only no difference. And now assume the group one, assume they are from some state in the US, and the red one from the middle state, the middle of the United States, and the white one, sorry, the yellow one could be from the east, certain state in the US of the US. And we want to know. Sorry, I got an important phone call. I'm apologizing.